Hello everyone. So we are going to keep talking about arithmetic sequences today, and more specifically we're going to start talking about how do we use the explicit formula to our advantage. So in our previous video we talked about how you determine if a sequence is arithmetic or not, determining the common difference, identifying different terms. So we're going to build on that a little bit today. Now the first thing that I do want you to copy down, so you could pause the video here so that way you could get this down, is I want you to recopy the explicit formula as well as all of the little notes that I have. So you have this on the previous page, but you might as well put it on this page as well. So the explicit formula, a sub n is equal to a1 plus d times n minus 1. Now a sub n is just the notation that we use for whatever general nth term that we are looking for. So if I was using the explicit formula to find the 105th term, it would be a sub 105, and we'll get more into that. A1 being your first term, D is your common difference, so that's what you're going up or down by each time, and then N is the number of terms that you're dealing with. So let's start with this example. So if we are given this sequence of 15, 12, 9, and 6, dot, dot, dot. Let's find the explicit formula. So let's just first practice again that finding the explicit formula piece. So remember, for that you need your common difference. So you need D is equal to, in this case here, we are going down 3 each time. So D is equal to negative 3. Make sure that you note it's negative 3 because you're going down. And then A sub 1 is your first term in the list, whatever the very first number is there. So it's 15. So plugging into my formula, A sub n is equal to, I'll just rewrite it all, A1 plus D, then times n minus 1. There's only two things that I'm plugging in to create this formula. So A sub n is equal to, this will be 15 minus 3 times n minus 1. So remember your order of ops. You want to distribute here. You wouldn't do 15 minus 3. So A sub n is equal to 15 minus 3n plus 3. And then when you combine like terms, A sub n is equal to 18 minus 3n. So that is your explicit formula for this sequence. Now using that, let's find, so let's skip a line here. So given our explicit formula, A sub n is equal to 18 minus 3n, so we're just using this one. Find the 80th term. Now, there is a way that you could go back to your original list up here. These are the first 4 terms. You could start counting it all the way out to 80. It's a very tedious process and one that we don't want you to get into the habit of doing. So we're going to teach you how do you use the explicit formula to find a term that's like way off into the distance from what you were given. So this part here, finding the 80th term, that means that your n is 80. N represents the numbered term that you're looking for. So in this scenario, n is going to be equal to 80. So if I use this formula here, a sub n is equal to 18 minus 3n, I'm just taking 80 here and I'm plugging it in for n. So what we're doing is we're finding a sub 80, this being the notation for the 80th term, and I'm simplifying it in the equation. So equals 18 minus 3 times 80. And then I just have to evaluate. So a sub 80 is equal to 18 minus 3 times 80 is 240. And then 18 minus 240, we get negative 222. So the 80th term is negative 222. Now, there's another way to use this explicit formula given a different scenario here. So let's say, here's our second example. If I am given a sequence where a sub 1 is equal to 6 and d is equal to negative 1, let's find the 21st term. So given a sequence where a sub 1 is 6 and d is negative 1, find the 21st term. Well, we could go through and make the explicit formula using these pieces here. So a1, and then your common difference is negative 1. And then we're also finding the 21st term. So that means n is equal to 21. Now, the easier way to approach this is our formula here, a1 plus d times n minus 1. We're using these three pieces. a1 is equal to 6, d is equal to negative 1, and then because I'm trying to find the 21st term, that means that n is equal to 21. So I can go in and plug all of these things into my formula. Plug 21 in for n, so you're finding the 21st term. Plug negative 1 in for d here, and then plug 15 in for a1, or I'm sorry, 6 in for a1, and then just simplify. So you'd have a sub 21, because you're finding the 21st term, is equal to 6 minus 1 times 21 minus 1. So instead of creating the entire formula first and then plugging in 21, I can go right to the explicit formula and say, I know the first term, I know the common difference, and I know what term I'm looking for, and then just evaluate. So order of ops tells us that we have to do inside the parentheses first. So that gives us 20 on the inside. So a sub 21 is equal to 6 minus 1 times 20. So when you multiply there, a sub 21 is equal to 6 minus 20. So a sub 21 is equal to negative 14. Negative 14 is the 21st term. Now, another way that we can use the explicit formula to our advantage is determining if numbers are actually in a sequence or not. So I could give you an explicit formula, or I could give you a sequence and say, you know, these are the first four numbers that you see. Is another number going to be in this sequence based on what you see? So let's see an example of that. So let's maybe add in like a header here. So determining no, I didn't spell that right. If a number is in a sequence. So changing it up, we're now going to determine if a number is in a given sequence or not. So here's our first example of that. So is 92 a term in the sequence given by a sub n equals 2n plus 4. So we're trying to determine, is 92 in this sequence that exists? Now, you could start using this to find like the first couple numbers of your list, but like how much work is that going to be to try to make your entire list to see if 92 is going to pop up? So what we're instead going to do is we're going to say, well, if 92 is in our list, then it would have to equal our formula here and work out correctly. So I'm going to take 92 and plug that in for a sub n. I'm just replacing a sub n with 92. So 92 is equal to 2n plus 4. Because what's going to happen as we're working through this, so if I'm solving for n, let's subtract 4. I get 88 is equal to 2n. And then I divide by 2. And we get n is equal to 44. Now, that's important to note because this answers our question. Yes, it is the 44th term. 92 is the 44th term in our sequence here. So if you were to plot the first 40 terms of this list, you would see that 92 is in there. Now, another example, and we're going to compare and contrast how these come out here. So is 105 a term in the sequence a sub n equals 3n minus 2. So similar question. Now I'm trying to figure out, is 105 here in our sequence? So I'm going to take 105 and plug that in for a sub n here. So we're setting 105 equal to our explicit formula and solving for n. So we have to add 2. You get 107 is equal to 3n. And then when you divide by 3, 107 divided by 3, you get this number, 35 and 2/3. Or if you did it in your calculator, you get 35.6 repeating, 0.67, whatever it would come up with. But basically, note that it is not a whole number, right? It's not 35, it's not 36, it's 35 and 2/3. So because that happens, it means no. 105 is not a term in the sequence because n must be a whole number. So when you're solving these, if n comes out to be some number that's a decimal, you know that that number cannot be in your sequence, because what would happen is that as you're listing this, you would go like 104 and then 108, and 105 is like in between there someplace. That's just a general example. I don't know that those are the 35th and 36th terms, but 105 is in between those two numbers, but it's not a whole number in itself in that sequence. So copy down these examples into your notebooks. We'll be going over this the next time that we meet in class. Let me know if you have any questions. Have a wonderful day, everyone.